Hi, this is Rick for EDU Mobile Academy. Welcome to our third application. This is called Mini Pong. Pong was a game developed by Atari way back in the 80s, and it was just a simple game where we had a ball that moved around, and the ball was square, of course, and we had a paddle. Now, I haven't implemented the paddle as yet, but we will do that. The first step in developing this sort of game is to implement the ball just colliding with and bouncing off of the edges of the screen. So that's what we're going to do first. Now we can see that we have just a very simple layout. I've chosen a linear layout here. We could use a relative layout. The layout doesn't matter at all because we're going to put a new canvas or a new view and on top of this layout. Now the view, unless we do something else, is going to be transparent. So our main layout is there pretty much just to give a background color of all black with an alpha channel of FF, or a full alpha. Alright, so here is how we import a new view inside of our existing linear layout, or our existing layout file. And we'll see this happen in main activity as well, but let me just go there first. In main activity, we're loading r.layout activity main. Activity main, in turn, contains a background view object. Com, EDU Mobile Dev, Mini Pong is the package name, and then background view is our class, and we've set it to have an ID of anim view in case we ever need that, and then a layout height and a layout width of filling this container's parent. Alright, so let's look at background view. Well, hang on. Before we do that, let's look at the Android manifest, because we are dealing with our own canvas here, our own view object. We need to handle screen orientations. I've done it very simply. I've said the screen orientation is portrait, and the config changes are orientation and keyboard hidden. Very, very simple, but we do need to do this within our activity. Alright, so now to background view. Background view defines several important parameters here. We have a context object called context. We have a float x and y. This is the position of the ball, initially set to -1. We'll get to y here in a moment. But -1 is a can't happen sort of value. The first time that these positions, or the first time that this canvas is drawn, we will recalculate these based on the fact that they're both negative. I've also created a new class called velocity. We could keep these separate as x and y, but I wanted to group them together. So we have a new class called velocity, and it's a new velocity with an initial x vector, if you will, of 10 and a y of 15. Looking at velocity very quickly, it's exactly what you might expect it to happen. It's a float x and y. These are basically what will happen next, the delta x and delta y of the ball. So the constructor just sets this x to x and this y to y, the parameters we pass in. And then we have get x, get y, and set y, of course. So we need these getters and setters because we make this private. We make it private for purposes of encapsulation. It's a good object-oriented thing to do. So we have velocity. Velocity is just a vector holding the delta x and delta y for the next time the ball appears. So initially, we can think of velocity as the moving velocity of the ball. So we're moving 10 in the x direction and 15 in the y direction. This is hard-coded initially. However, this gives us the option to change the velocity vector for the ball at any time we want by using set x and set y. We've also defined a handler here called handler because every time we draw, we want to update the velocity, or not the velocity, but we want to update the x and y position. And we'll see that being done in the onDraw method for our view here. Update millis is the delay in milliseconds that will be used by the handler to call the runnable that we'll look at in a moment. Paint is the attributes, the painting attributes of the ball. We're going to use DrawRect right on the canvas to make a new ball or to repaint the ball. And then we have a radius. Well, the ball is square, but the radius is taken to be the difference from the edges to the center point. And here I've kind of arbitrarily said, okay, I want my ball to be 40 pixels wide and 40 pixels tall, so my radius here is going to be 20. So now here's the constructor. We're passing in a context and an attribute set. We pass that through to super. We set this context, this guy, to whatever we pass in, the context. And then we set up our handler. Handler is just a new handler. We'll use it in a bit. And now we're setting up the paint. The color is going to be white. The style is going to be fill. So I want a white solid square. And then to kick things off, we're going to call invalidate on the view. The runnable is what's going to happen every time the handler needs to update the view, needs to update the ball. Again, we'll see that in a moment in on draw. So its run method just invalidates the view. Very simple. And then in on draw, if x and y are both negative, so if x is less than 0 and y is less than 0, we have an initial condition and we need to draw the ball. So x we're setting to get width over 2, and y we're setting to get height over 4. So this will position the ball initially in sort of the upper center quadrant of the screen. And then we want to check to see if the ball has collided with the edges. This is a simplistic way of handling this, but for now it will work just to get our application kicked off with the ball being able to hit an edge and bounce off in the way. So if we think about what we really want to do, what we're doing is, if the ball hits an edge, we could think about the angles and try and reverse that angle and all of that stuff, but really it's a lot simpler than that. If the ball hits an edge while it's on its x dimension, whether x is positive or negative, all we do to reverse the angle or bounce the ball off the edge is reverse the x part of the velocity. So if x is greater than getting the width minus the radius, or x is less than 0 plus the radius, we want to set velocity, the x component of the velocity, to whatever it is times -1. We do the same thing with y. This will bounce the ball if it hits a horizontal or vertical edge. And of course we want to do the same thing if the ball hits the paddle when we implement the paddle. So this just reverses the angle and keeps the ball inside the screen and bounces it more or less realistically. Then finally we draw the ball on the canvas. We draw the ball on the canvas by just using a DrawRect call, and it's x minus radius, y minus radius for the top and left coordinate, and then x plus radius and y plus radius for the bottom right coordinate for our rectangle. And then we use the paint, which remember is a solid fill and a white background color, or a white color. And then we tell the handler to post delayed the invalidate command that's in the run method of that runnable in and wait for update millis. That's the delay part of the post delayed before it tries to do so. So millis is set to 30, so every 30 milliseconds, more or less. Now, if we're on an actual device, this is going to be more like 30 milliseconds. But since we're in the emulator, it's going to be more and or less than 30 milliseconds whenever the emulator can get to it, pretty much. So let's go ahead and run it and see our initial attack at getting the ball to bounce around the screen. One caveat here is that I may change things here in our bouncing code and things like that, but I will tell you when I do so. So I've gone ahead and told it to run. And I'm waiting for it to come up and ask me what I want to run it on. And yes, I want to run it on that Nexus emulator. And now I'm going to go into the emulator and wait for it to run. So here we go, and it's not too bad. The ball is bouncing around the screen. It's kind of deterministic. In other words, I've set up an initial condition where we have, remember, our velocity is 10, 15. If I change this, or possibly when I hit a paddle, I'll want to increase the speed, which I can certainly do that. I could change the angle each time that we needed to reset. Perhaps if the ball fell below the position of the paddle, we would recreate the ball in other words, set ball X and Y to -1 again and allow it to recreate the ball up at the top, and then change its velocity vector so the angle were different with randomization or something like that. But we can see that our ball is running. It's bouncing off the four edges of the screen just fine. So we have accomplished our first goal, which is to get the ball to bounce around the screen. Thank you.